Alright, so here we're going to be adding and subtracting rational expressions. In order to do that, we're going to need common denominators. So for the first example, if you notice, we have common denominators in all 4 examples. So we could just go ahead and add across. So this would be x plus 5x over 4, and it gives you 6x over 4, and then you could go ahead and divide these out. So 6 and 4, I could divide both of those by 2. I get 3 over 2. Alright, the next one, we have 5 on the bottom, 5 on the top, and then x. So that becomes 5x over 7z squared. And that's as far as you could go because you can't simplify the 5 or anything with the top or the bottom. Alright, next we're going to go ahead and subtract now. So this is x squared minus 49 and then over x plus 7. Okay, and then whenever you see a quadratic, you should always try to factor. So I could actually factor this out to x plus 7, x minus 7, x plus 7 on the bottom. Those would cancel out. And you have x minus 7 as your answer. Alright, next one, we have x minus, and then I'm going to put parentheses around what I'm subtracting. So what I'm going to do is I'm going to distribute the negative. If you did not put the parentheses, then you probably would have forgotten to get a negative one. So these cancel out. You're left with negative 1 over 3y squared. Alright, so that's how you would add when you have like denominators. And then over here, we're going to go ahead and find the lowest common denominator or the common denominator of each pair. Alright, so we have 2 over 3x to the 5th y squared, and then we have 3z over 5x y to the 3rd. So what we want to do first is you want to make sure if you could simplify, you should try to simplify. And then if not, we're going to go ahead and look at the denominators. So you have a 3 over here, but you don't have a 3 over here. So you're going to need 3 in the denominator. And then you're going to need 5. And then when we look at the variables, you have x to the 5th and then x. So you usually want to take the highest. And then over here, same thing, the highest. So this would be your lowest common denominator. Alright, so for this next one, you have to think about this as one compartment. And then think about this as another compartment. So basically the lowest common denominator is going to be both of them multiplied. Alright, so let's go ahead and use that idea to add and subtract. Okay, so this first one, it does not have common denominators. So we're going to want to I like to look at the numbers first. So there's a 3 here. There's not a 3 in the first one, so we have to go ahead and multiply it by 3. Okay, then I could go ahead and look at the variables now. You have an x squared and an x to the 3rd, which means this one is missing an x. So I'd multiply it by an x. And then they both have y. So that's it. And then you just multiply these. So that gives you 6x. And then on the bottom you have 3x to the 3rd y plus 5 3x to the 3rd y. So now you have common denominators and you could add the tops. X plus 5 over 3x to the 3rd y. And you're done there. You can't factor anything out of the top. Alright, so this bottom one, remember these are compartments here. So this is one compartment, this is another compartment. Whenever you see binomials, it's just easy to multiply them by each other. So x plus 2, x plus 2 on the top, x minus 2, x minus 2. And then what you're going to do is I'm going to go ahead and rewrite it first before I distribute. And then the bottom is going to be x minus 2, x plus 2, x minus 2, x plus 2. So that means we could go ahead and distribute these. And then we're going to go ahead and simplify. Alright, so the top we could go ahead and combine 4x and 3x. And then we're just going to write it in standard form, which is from highest to least. So 2x squared plus 7x minus 6 all over x minus 2, x plus 2. And you can't simplify anything, you can't factor out that top, so that would be your answer. Alright, next we're going to go ahead and subtract. So we have 5x over k squared minus 4, 2 over k squared plus k minus 2. So we're going to go ahead and factor. So this bottom factors out to k plus 4, k minus 4, minus 2 over. This bottom factors out to k plus 2, k minus 1. So we could start seeing what we're missing. So they both are missing 2. Actually, this should be 2 and 2, sorry. So plus 2 minus 2. Okay, so they both have a k plus 2 in common. And so this one is missing the k minus 1. So you're going to multiply k minus 1 on the top, k minus 1 on the bottom. And this one is missing the k minus 2. So now they have the same denominator. So we're going to go ahead and write it as over 1. So 5k, k minus 1 minus 2, k minus 2 all over that denominator, k minus 1, k plus 2, k minus 2. We'll go ahead and distribute. So we get 5k squared minus 5k minus 2k plus 4. Rewrite this again. And then the minus 5 and minus 2, we could simplify that. So this would be 5k squared minus 7k plus 4 all over this. And that would be our answer.